Section 8.2. How to find the bug. Finding bugs can be challenging. Fundamentally, whether you or Copilot wrote the code, you thought or Copilot thought the code was correct when it was written. This is why it's often easier for a colleague to find a bug in the code rather than the author. The author can't see the bug because they created it. Bugs aren't new to us in this book, as we've seen mistakes in code already, and we've found those errors by reading the code and/or testing. In previous chapters, we figured out the source of the bug by reading through the code. In this chapter, we'll address the bugs that you identify when testing, but can't seem to figure out why the code is wrong. Often, you can bypass the process of figuring out why the code is wrong by trying other Copilot suggestions, using new prompts to fix the error, or asking Copilot to fix the bug for you. But in our experience, these techniques don't always work. What we need then are more tools to help us figure out where the error is in the code. Section 8.2.1. Using print statements to learn about the code behavior. Fundamentally, a logical error means that there is a mismatch between what the author thought the code would do and what the code actually does. A common way to identify that mismatch is by using print statements to get insight into the behavior of the program because they tell you what the computer is actually doing. A useful practice is to print variables at various points in time to see what the values of those variables are at those points. Let's try this for that example we just gave of looking for the word Dan in a list of words. Here's the wrong code.
Listing 8.1. Incorrect function for counting matching words.
You may already see what's wrong with the code, but let's assume we don't know what's going on, and we're trying to figure out where the code went wrong. Suppose we found out that our code is wrong by running the following test case.
See this code?
We expected the answer of 1, but we got 2. Notably, including danger in this test case helped us catch the error in the code. Where in the code did things go wrong? To figure that out, we could add print statements. When you want to do this, you'll need to read the code to figure out where to put them. Looking at this code, printing the list at the start of the function might not be a bad idea depending on the bug we're seeing, but the bug here seems to have to do with the count and not specifically with the list of words. Printing each word in the list as the first line in the for loop may be helpful so we can check that the code is processing each word. We might print count right before it's returned, but we already have a good idea of the value returned. These are all reasonable ideas that will help you get closer to the bug, but it's not where we'd start. To be clear, if we started with one of these other ideas, we wouldn't be wrong. It might just take a few more steps before finding the bug. Because the bug is counting too many words as Dan words, we'd put the print statement within the if statement right where count is incremented, as in the following listing.
Listing 8.2. Example of a print statement to find the bug.
Rerunning our code with the same test case, this is what is printed now.
See this code?
Aha! This would tell us that our program is counting the word danger when it shouldn't be. We could then give Copilot a new prompt incorporating what we just learned to hopefully have Copilot fix the problem. Here's the prompt we added in the editor, and Copilot fixed the code in the following listing.
Listing 8.3. Using a prompt to fix a known bug.
Once we knew the bug, it was easier to tell Copilot how to fix it. Granted, this is a basic example, but the idea applies to far more complex code. The process is often iterative. You ask the code to print something, and what it prints aligns with what you think it should be doing. You then ask the code to print something else, and check it against what you expect. You keep doing this until there's a point where what the code prints doesn't align with what you wanted it to do. That's when you've found the bug, and can give Copilot a prompt to help it give you better code, or if the fix is simple, you can change the code directly. Depending on the complexity of the code, using print statements is often an effective way of debugging. We often use it as our first step in debugging. Debugging, an art more than a science. The iterative process when debugging is necessary because we're genuinely confused about what the code is doing and why it isn't matching our expectations. It's okay to add a bunch of print statements that just tell you what you thought was happening in the first place, because each of these print statements tells you where not to look for the bug, and is an effective process of elimination. Figuring out where to look for bugs takes time and practice, so don't worry if you find yourself spending a fair bit of time on it when you first start. Section 8.2.2. Using VS Code's debugger to learn about the code behavior. VS Code is used by novices and professionals alike, so it has tools to help with the process of debugging. Because it's used by professionals, debugging tools have a large number of features. For the purpose of this book, we'll focus on a few of the most commonly used features, but feel free to look into more resources on using the VS Code debugger if you're curious. See this link. To showcase these tools, we'll work through debugging the same function from the previous example, refer to Listing 8.1, in a few ways. Listing 8.4 provides the code we'll be working with throughout this section. Note that we've added the test of the count words function to the program.
Listing 8.4, incorrect count words function for debugging.
Getting started with the debugger and setting breakpoints. To use the debugger, we need to set a breakpoint and start the debugger. Setting a breakpoint tells the debugger when you want to start debugging the program as it executes. Once you hit the breakpoint, you'll be able to inspect variable values and step through the program line by line. Breakpoints are extremely useful. For a large program, you wouldn't want to step line by line through the entire program because that could take a great deal of time. Instead, using a breakpoint, you can step through just the lines of code that are most relevant to you. To set a breakpoint, hover your mouse cursor to the left of the code, and you'll see a dot appear. Click that dot, as shown in Figure 8.1, and you'll have a breakpoint set. For your projects, you'll likely want to start by creating a breakpoint at the start of the function's execution, and then step through it one step at a time.
Figure 8.1. Creating a breakpoint in VS Code by clicking to the left of the line of code.
If you see a red dot to the left of the breakpoint after you move your mouse away, as shown in Figure 8.2, that means it's properly set.
Figure 8.2. A breakpoint has been set on line 2 of our countwords.py file in VS Code.
You can have more than one breakpoint, but for this example, let's just stick with the one breakpoint on line 2. Note that you can remove a breakpoint by clicking on that red dot again. Next, we'll start the debugger and see how it works with the breakpoint. How to step through the code line by line. To start the debugger, choose Run, then start debugging, as shown in Figure 8.3.
Figure 8.3. Starting the debugger in VS Code.
Once the debugger is started, you should see a screen similar to Figure 8.4. If this is the first time using the debugger, it may ask you to select a debug configuration, in which case you'll want to choose Python.
Figure 8.4. The debugging view in VS Code.
The VS Code debugger has a number of components. On the left-hand side, the debug sidebar contains the variables section, watch section, and call stack section. Let's briefly examine each of these sections. The variables section contains the variables that are declared within the current scope, for example, within count words, and their current values. For example, the word's parameter is defined to be a list containing Dan, Danger, Leo. You can click the arrow to the left of words to see more details about that variable. This section is incredibly useful because you can examine the value of each variable. The watch section contains any expressions you want to watch specifically. For example, you might add the expression Dan in word.lower to the watched expressions, and you'd be able to see if it's true or false for each different value of word. To add an expression, hover over the watch section and click the plus sign. The call stack section contains the functions that have been called that have led to this line of code executing. Here, the main function, called module by VS Code, called the function count words on line 9. Within the function count words, we're presently on line 2. You can double-check that this is true by looking at the line of code presently highlighted as line 2 is highlighted in Figure 8.4. Speaking of which, on the right-hand side, which shows our code editor, we can see the line count equals 0 highlighted. This is the current line of code that hasn't yet been executed. The reason the line hasn't been executed yet is because we set our breakpoint, shown by the arrow with a dot in it, at this line of code. When we started the debugger, it ran the code until just before executing count equals 0. The debug toolbar, Figure 8.5, is critical as it drives the process once you start debugging. You can advance an instruction, restart debugging, or stop debugging.
Figure 8.5. The debugging toolbar.
The buttons on the toolbar going left to right are Continue, F5. This button will advance until the next time a breakpoint is executed. In our example, line 2 of count words never executes again, so clicking Continue will cause the program and debugging session to run to the end. Step over, F10. This button advances to the next line of code in the current function. Step over means that if a line of code in this function calls another function, for example, when word.lower is called on line 4, the debugger will stay in the countWords function and will just run the called function, for example, word.lower, to its completion. Step into F11. This button advances to the next line of code, including going into any functions that are called. Unlike step over, when you use step into, the debugger will go into any function called by the current function. For example, if you used step into on a line of code that calls another function, it would go into that function and continue debugging, line by line, from inside that function. By default, it doesn't step into library function calls. For example, word.lower is part of the Python standard library, but will step into functions you've written. Step out, Shift plus F11. This button will execute the code until the present function ends and then continue debugging from after this function's exit. Restart. This button restarts the debugging process. It will restart the program, and the program will execute until its first breakpoint. Stop. This button stops the debugging process. Stepping through the code line by line. Now that we have a handle on the debugger, let's continue our example by using the Step Over button. Let's click Step Over once and see how our view changes. Figure 8.6. Step Over advanced to the next line of code, line 3. This means it executed.
See this code?
And is just about ready to execute.
See this code? Figure 8.6. Our debugger after clicking Step Over once. The next line, line 3, is now highlighted.
We can see from various clues in the interface that the line count equals 0 was executed. First, in the editor on the right, we can see the for loop is highlighted, and the arrow on the left points to this line of code. On the left, in the call stack section, we can see that it's now on line 3 of countWords, as shown by the line countWords being highlighted, and the number in the oval on the right reading 3:1. Perhaps most importantly, on the left in the variables section, we can now see the variable count has been added to the local variables, and it has a value of 0. This last piece is pretty amazing because if you were trying to read through the code and trace what is happening line by line, the line count equals 0 on line 2 would mean that a variable count is created and assigned a value of 0. This is just what the VS Code debugger has told us as well. We hope you're starting to see how powerful this tool can be. Let's click Step Over one more time. Now we're stopping just before the line.
See this code?
We can see that there is now a new variable word, which has been assigned the value Dan, and that's just what we'd expect. Word was given the value of the first element in the list words. This is a good spot to point out that in addition to being able to read the variables values in the variables section, you can also just hover your mouse over any variable that's been declared already to see its value as well. Pretty neat, huh? Let's click Step Over one more time and see that the condition in the if statement, Dan in word.lower, evaluated to true, so we're going to execute the line.
See this code?
Now that we're getting the hang of this, let's keep clicking Step Over a few more times. The first time you click Step Over, it will go back to the for loop, and you can see count has incremented to 1. The second time you click Step Over, it will stop at the if statement, and you can see that word is now danger. We could stop here and add a watch expression to see what this if statement will do. To add a watch expression, hover your mouse over the watch section, and click the plus arrow that appears to the right of the word watch. This will let you type anything you want. We typed Dan in word.lower and pressed Enter to add this watch expression, as shown in the debug sidebar of Figure 8.7.
Figure 8.7. View of the debugger after adding the watch expression.
If we hadn't already found the bug earlier in this chapter, this is where we'd find it. The expression Dan in word.lower evaluates to true, which means count will be incremented again. But we only wanted exact matches to the word Dan and didn't want danger to count. This is a completely reasonable way to debug a function. As we noted earlier, putting a breakpoint at the start of the function's execution and then stepping through it one step at a time often is a great starting point for debugging. The only times you might struggle to use this approach is if the for loop ran through thousands of values before making a mistake. To address challenges like this, we might put a breakpoint in a specific spot to avoid spending a lot of time in the debugger. Let's stop the debugger, click Stop in the Debug toolbar, remove the breakpoint from line 2, click the red dot to the left of the line, and try a different breakpoint. Using a breakpoint to selectively debug. This time, let's put the breakpoint at a point in the code we want to monitor more closely. based on our test case showing that 2 words of the list counted when we expected just 1 to. We should try putting our breakpoint at the line where count is incremented, as we have in Figure 8.8.
Figure 8.8. View of the code after placing our new breakpoint on line 5.
Once we start the debugger, the code will run until the first time the if statement is evaluated to true, and the line count plus equals 1 is ready to execute. Figure 8.9 offers the view of the debugger once we start it.
Figure 8.9. View of the debugger when it encounters the breakpoint, line 5, for the first time.
We put the breakpoint at the incrementing of count because we wanted to see what item in the list is causing count to increment. Examining our local variables, we can see that word is Dan, and that is when we want the count variable to be incremented. Given this is what we wanted to happen, we haven't found our bug yet. Now is when we can really take advantage of our breakpoint placement. We want the code to execute until it comes across the breakpoint again. The way to do this is to click Continue in the Debug toolbar, refer to Figure 8.5. After clicking Continue, the debugger should appear as in Figure 8.10.
Figure 8.10. View of the debugger when it encounters the breakpoint, line 5, for the second time.
In the Variables section, notice that the value of count and the value of word are highlighted. This is to tell you that because you clicked Continue, those two values have changed. The value in count increased to 1, as expected, after having found the word Dan. The value in word updated to danger. Although danger is the next value in the list of words, we shouldn't expect to find the code incrementing count for the word danger. At this point, we'd have found our bug. Notice how much quicker it can be to find a bug with a good placement of a breakpoint. But we caution that knowing the best place to put a breakpoint is a lot like knowing the best variables to print when debugging. It takes time and practice to learn how to do it well. In this section, we've seen how powerful the debugger can be in VS Code. It's pretty easy to set a breakpoint and start a debugging session. As the debugger monitors the variables in the function, you can inspect those in the debug sidebar as the code executes.